Assalamu alaikum, my dear students. How are you? Hope you'll be fine and okay. I welcome you all and to my today lecture. This is the last lecture of our scheme of studies, and it is about the building blocks of matter. All right. So here we will discuss the building blocks of matter. So let us start with the name of Allah Almighty. Bismillah ar-Rahman ar-Rahim. The building blocks of matter, there are few important uh, points which I want to explain to you, and most probably I already explained to you if you remember my very beginning lecture when I was introducing to you to the electricity. Then at that right point I told you about the classification of matter, and if you remember my date lecture, there I told that we can the classification of matter, that what is matter made of classification of matter. I will do it quickly. And if you remember, I told we have three kind of classification: the physical kind of classification, and then I told the chemical kind of classification, and then I told that on the basis of electrical classification, right? And there then in the physical, I told that we have the solid, the liquid, the gases, and the plasma. And in the chemical, I told mixtures, compound, and then I told that the chemistry teacher might further explain you that compound, the organic and the organic and the mixture, the homogeneous and the heterogeneous, and what that whole story is. And on the electrical classification, if you remember, I told that we have metals, non-metals, metallites, or semiconductors, or insulators, and the conductors, right? So, and then I told that whatsoever is that they all are made up of what? Every substance is made up of molecules. And then I told that molecules are further made up of atom. And then right in the beginning of this nuclear chapter, I told what is atom, and then I told what is the nucleus. And even today we will see what is inside the nucleus and what is in fact proton and neutron are made up of, and I'll introduce to you about the quarks also. So these particles are in fact the called the building blocks of matter, and we classify them into hard-ons. I'm very sorry, the spelling I wrote here wrong. There is no R here. Okay, sorry for that. So we have the this whole I will write again for this. I don't the hard round. This was a typographical mistake, and I'm sorry for it. And we have the leptons and we have the quarks. So let me introduce to you, and we start from, for example, if you look around you, and what do you think makes up of all the items in your study room? The possible answers are atoms, matter, solid stuff, etc. Some students may answer more concrete like things such as his or study desk, wall, air, pens, lamp, box, and the laptops which you all see here. So what all these stuff made up of? And the answer is, of course, matter. So if you remember, I told you that matter is the stuff from which the universe is made up of. And here at this point, I also want to tell you that I may be told this thing to you also very early, that our universe is in fact made up of matter, space, time, and energy. These are the constituents of our universe. So the universe consists of matter, space, time, and energy. And I explained to you about the matter, space, time, and energy at their appropriate place. So matter is a long story short, the stuff. It is the stuff from which the universe is, from which the universe is made, from which the universe is made. So matter, the common definition which you usually often state as matter is anything which has mass and occupies space. So very simple, that matter is the stuff from which our universe is made. Now the bigger question is that, do you know that what the basic building block of the matters are called? And of course we call them atoms, right? If you remember, I told that they are called molecules, but to the most, the building blocks of that matter, the entire matter is in fact made up of what? It is made up of atom, right? If you remember. So if you see, look, that in the previous lecture, I told that atom is nothing but it consists of what? It, the atom consists of it consists of a nucleus with orbiting with orbiting electrons, or electron if it is hydrogen, right? So that is the atom. And the nucleus, I already told about the nucleus also, that the nucleus is in fact the in the previous topic I told, or maybe in the beginning of this lecture, that it is the highly dense, it is the central, highly dense, and positive charge part of the matter. And the positive charge part of the matter, where it is home to proton and neutron, and I discussed their size with you in great detail. So these are the building blocks of our matter. And molecules, to be very simple, is in fact the group of atoms. The group of atoms is called molecule, which may or may not be similar. For example, similar in case of H2 and non-similar in case of H2O, maybe. So the basic structure of the matter is that of which is made up of is actually the atom itself. And in the past, or in the Greek, atom was considered to be indivisible, but now it is in fact divisible, right? Because atom, it consists of electron, proton, and neutron. And here you would see it like here in this diagram, as you see the atomic size in centimeter and meter. I would like to explain. So if you see here, look in this diagram, if this is the atom, and now the atom is consists of the nucleus, as you see here. This is the what the nucleus is. I take it out of the atom, and you see here it is the orbiting electron. And if you just see the size of the atom, so the size of the atom is 1 into 10 of the order of 1 into 10 to the power minus 10 meters, so it is extremely small. And if you see the size of the electron, that is not exactly known, but you may think of that it is at around the 1 into 10 to the power minus 18 meters. So this is much more smaller than the size of the proton, right? And here you see that the 1 over 10,000 part of the atom, here you see this is the nucleus. And now if you see, look inside the nucleus, there you will find the proton and the neutron. And the size of the nucleus, as I already told about the structure of the nucleus, that it is 1 into 10 to the power minus 15 meter to 1 into 10 to the power minus 14 meter. And this is not exactly facts, because in my last lecture, if you remember, I told that the radius of the nucleus is directly proportional to the 1 over cube root of the mass number, right? If you remember this. So this is not fixed. As the number of nucleon increases, the size or the radius of the nucleus increases. And then if you just pick one proton out of the whole story, then the neutron is in fact of the size of 1 into 10 to the power minus 15 meter. One proton is of this size, and it is the same as that of the size of the hydrogen atom. And then you will find quarks, and the quarks ranging below the 10 to the power minus 14 centimeter. And the quarks then further consist of up, down, top, bottom, charm, and strange. And I will explain this to you. Similarly, if you see here, look at the structure. Here the atomic structure. Now look, you see here the electron as its orbit around the nucleus in elliptical orbits. And here you see the size of the atom. And then here you see the here you see the nucleus, which is size of 10 to the minus 12 centimeter. And then down, if you see the size of the nucleon are actually proton neutrons together. And you see that they are of the size of 10 to the power minus 13 centimeter. And then the quark, and as I told, the quark has the size of this. Now I just want to tell you, and I want to write it here so that I may not forget it later, that if we consider the particles, the fundamental particles, the only fundamental particle is out of the 3 electron, proton, and neutron I talk about. The only fundamental particle is electron. Particle is electron. In junior classes, your teacher might have told electron, proton, and neutron, but it is not the case. The only fundamental particle is what? Electron. Why? Because electron is not made up of any other particle, while the proton and neutron, these are not the fundamental particles. They are not the fundamental particles. I call them usually the composite particles, because they are composed of what? They are composed of, or they are made up of other particles. We call them quarks, rather the combination of quarks. Proton is also made up of 3 quarks, and neutron is also made up of 3 quarks. And there is the proton and neutron and electron by itself, they have integer charge, but the proton and neutrons are made up of the quarks, which have which charge are not integers. They are for the half integer, you may say. So now let's see that if we just see the classification of the particles. So the classification of the particles, we have the hard-ons, right? The entire classification of the particles. When we have the hard-ons and we have the leptons. So hard-ons are, in fact, these are the particles that interacts through strong force, right? That is, in all hard-on, they interact through strong nuclear force, through strong nuclear strong nuclear force. They interact through the strong nuclear force, and they are classified further as the as the baryons and the mesons. uh, they are classified into these two. The meson has mass between that of electrons and protons. The mesons particle have mass between the electrons and the protons in between them. And all mesons are usually decay into electron, positrons, neutrinos, and photons. So these kinds of particles are usually means this group of particles have mass between they have between mass between the electron and proton. They have mass between them, these group of particle, and now you can search or you can see the mesons group, the group of those particles, right? And when they decay, so they finally decay into electron, positron, neutrinos, and photons. One example, for example, I will give you of the rest. I do not remember, but like for example, the ion are the particles which belongs to the mesons groups, while the baryons are protons and neutrinos, and they interact with a strong nuclear force, as I told, and they have mass. Equal to proton or greater than photon. For example, the mass of the protons, of course, you know, and neutron have slightly greater mass than that of the proton, right? And it belongs to this family. There are other particles also which may belong to this group. All such particles decay, that is they decay in a way that their end products are protons, right? And then we have the leptons. So leptons are the group of particles that participate in the weak interaction, right? Weak interaction are bound through weak, they participate into the weak interactions. These are usually, you may say that, for example, as I told, electron being as the fundamental particles. Okay, they do not experience, these particles do not experience strong nuclear force. So of course you cannot find them inside the nucleus. These particles includes the electrons, muons, and neutrinos, and these particles are less massive than proton and neutron, that is the baryons. Leptons are in fact the fundamental particles, so they do not have the internal structure like proton and neutron. As I told, that proton and neutrons are the composite particles. As I told, they are what? They are the composite particles. They have internal structure. Have what? Have internal. They have internal structure, while these particles, they do not have any, don't have any internal structure. Internal structure. They are not made up of any other particle. This is why I call them the fundamental particles. Long story short, we may call them the elementary particles, right? Which particles? The elementary, yeah, can be called as truly the elementary particles, right? Because they don't have any internal structure. They are not made up of. Now, then there is another group of particles. We call them the quarks, and the quarks model is based on the assumption of, I'm coming to that on what assumptions they are actually made up of. That you see that there are 6 kinds of quarks. We call them the up quark, uh, the up quark, the down quark, strange, shorn, bottom, and the top quark. There are 6 quarks. These 6 quarks, the up quark, the down quark, the strange quark, the charm quark, the bottom quark, and the top quark are denoted by these symbols as you see here. And let me tell you about some of their properties to you. For every quark, there is what, just like for every other particle, there is anti-particle. Then for every quark, there is what? There is anti-quark also. There is anti-quark also. So we have a corresponding anti-quark for them. That is the quarks. It's hard to find. Why? Because of the problem is that they usually the quarks combines in the form of 3 particles. In the form of what? In the form or the combination of the three particles So any combination can be, out of these 6 there can be any 3 combination of any 3. And as I told, that there is one strange thing about is that individually, why they do not exist separately. Because one important point, this is what I want to write it here for this. This is a very important point, and the important point here is they do not exist separately. They do not exist separately because they have charge integral multiple of what they odd integral multiple of that is they have the charge they have the charge they have the charge they have the charge what sentence I can tell about this okay, they have the charge which is okay, which is not the integral multiple of the fixed value, yeah, which is not the integral multiple of the charge on electron, of the charge on electron, yeah, plus minus e. It is not the integral multiple of this. Okay, for example, here for electron, proton, that you have the charge is in the form of integer. Here it violates this condition. So this is one of the law of conservation of the charge. If you remember, that it violates very simple. Thanks God, I just got it. That is that they do not obey the quantization principle. The quantization principle. They do not obey the quantization principle. That charges are what? If you remember, as I told, charges are quantized. They always occur in integral multiple of a fixed value. Integral multiple of fixed value 1.6 into 10 raised to the power minus 19 coulomb. Right here it is not the case. The charge, they do not obey this. So this is why the quarks do not they do not exist in isolation. Rather, they exist in a kind of combination. Right, for example, I would like to tell you that just one simple example I want to tell. For example, look, as I told, look at the proton. Right, there is the proton and neutron example as being composite particle which are made up of proton. So now let us see here proton, and let you will see here the neutron. And now first let me tell you about the charge on them. In term of the charge of the electron, the charm and the top quark each carry a charge of plus 2 third of the charge on electron, the up quarks. So the charge on the up quark, this is the up quark. So up quark have charge of what? That is, it has charge of plus 2 by 3, 2/3 on the charge of the electron. So you see that it is not in an integer. This is what I was telling. And similarly, this is for the charm also. Here is the charm. It has charge of plus 2 by 3. The charge of plus 2 by 3. The charge on is the charge on electron. And similarly, on the top, have also a charge of plus 2 by 3 is that of electron. Now this is the charge on what? This is the charge on the charge on the up charm and top. Now the remaining three, they have the charge of what? 1/3 of that of electron. Here minus 1/3 is that of the electron, and all the rest the same here. Minus 1/3 is that of the electron, and here minus 1/3 is that of the electron. So here they have the charge. So this is these are the charge on the charge on the quarks. So now let us see, for example, as I told, proton. Look, what is the charge on the proton? So you see, charge on proton is equal to what? The charge on proton is that of equal to plus E, right, they equal to the positive charge it has, and its magnitude is equal to, that is the charge on electron. So you see that the proton is in fact is composed of this proton. It is made up of two up and one down quark. So if you see, look, proton, we have this proton now, as you see. And this proton, it is made up of two up quarks, up quark, two up quark, and one down quark, as you see. Now look, if you see on the list, the charge on this is what, that it is equal to twice theta, sorry, there is theta of the charge on electron plus E. Now we will look what is the charge on the up quark. It is plus 2 by 3 of E, so twice of this. And what is on the down, minus, that is on the down, the charge is on the down is minus 1 over 3E. So if you just do this calculation, so what is the charge? The charge here is what? The charge here is equal to plus E if you add all of these. Similarly, if you just see, look, the one neutron which has no charge, and now look, you'll see the neutron has no charge, and your neutron is made up of the two down quark and one up quark. Up quark plus two down quark plus down quark. So as there is no charge on the neutron, it has zero charge. Now you will see. So what is the charge on the up quark? The charge on the up quark is the that's equal to plus 2 by 3 and here it has a charge of minus 1 over 3. Right? So if you just see, look, they'll all together add up to what? It will add up to this is let me any neutron consists of up quark and down quark two down quark. So okay, and this is the why here it is not coming 0. Oh yes, here it is down quark. So definitely for this down quark, it has the charge of like this, right? So it will, when you add, it will give you what? It will give you 0. Clear? So this is the charge on what? This is the charge on the charge on the neutron is 0. So you have seen that they are what? That they are the composite particle, right? They are what? They are the composite particle. Now there are anti-quark also, as you know that for every particle there is anti-particle, and anti-quark carries an equal and opposite charge to its corresponding quark. And the symbol for the anti-quark is the same as for the quark, but with a bar over the top. So look in the list, I will just write here that for this there is what okay, let me do this here. That for what, there is, this is another property, that for every quark, for what, for every quark there is an anti-quark in the same way as for every particle there is anti-particle. For example, for electron the anti-particle is positron. So for the quark there is an anti-quark, and the symbol of the anti-quark is the same as that for the quark, but with a bar over the top. For example, like the up quark can be denoted by like this, the anti-up quark, the anti-down quark, the anti-charm quark, and the anti-top quark, and the anti-bottom quark, and the anti-strange quark, right? So they have like this one, and they have of course the opposite charge, and then okay, and they all have what? All have the opposite charge. All have what? The opposite charge. They all have the opposite charge. For example, the charge on the anti-up particle, it will be minus 2 by 3 e. For example, for this charge will be minus 2 by 3 that of the electron. So these were all about the fundamental particles of the matter. So the entire matter is made up of all these particles, or the combination of these particles. So thank you very much for being here, and this is the last topic of our scheme of studies, and I'm glad that we have finished the entire syllabus. Hope now you will revise every chapter, and if you have any problem you can ask me directly through my WhatsApp. And now soon inshallah we will be starting the series test for you also, and you will be getting notification about this. So pull off your socks and be ready for the test series also. Okay, so thank you very much. So inshallah see you again there.